Alright guys, so last week we talked about step 1, 9.1. Verify that a correlation is significant. Found our correlation coefficient, we decided if that meant something or not. Step 2 is determine the equation of a line that best fits that data. We said we'd graph our scattered plots, and if it had a linear regression, there would be a straight line that went through it. Now we're going to learn how we find that straight line. Okay, the line is called a regression line, and it is used to predict the value of y for a given value of x. So we're saying any value of x. If I say it's 2.1, you plug it into our equation, you're going to get a number out. A residual is the difference between an observed y value and the predicted y value. It can be positive, negative, or 0. So the y value we get out from our data doesn't always match. So that residual, whatever the difference is between those two values, what you actually got and what you were supposed to get. The regression line is the line for which the sum of the squares of all of the residuals is a minimum. So what it's saying is a regression line is the line where it's very small. All those residuals are very small. Okay? My bad. Alright. A regression line, also what we are probably going to call it, is the line of best fit, is the line for which the sum of the squares of the residuals is a minimum. Remember algebra. Y equals mxb, where m is the slope and b is the y-intercept. The equation for a regression line, linear line for an independent variable x and a dependent variable y, it's y hat equals mx plus b, where y hat is the predicted value of y for a given x value. The slope m and the y-intercept are given by these two equations. M equals n times the sum of all x times y minus the sum of x times the sum of y, all over n times the sum of x squared minus the sum of x to the power of 2. B is equal to y bar equals mx bar equals the average of y, the sum of y over n minus m times the sum of x over n, where y bar is the mean of the y values in the data set and x bar is the mean of the x values. Going back to that first chapter, our average, our mean. The regression line always passes through the point, the average of x and the average of y. The regression can be used to predict y values based on x values inside the data's domain. This is important, that it's inside of the data's domain, because outside of the domain can be unpredictable. So, important things to note in these equations. Y is predicted. Right here, your y value really is, your y average is the sum of all your y's all over your sample size n, and your x is really the sum of all your x's all over n. Okay? Regression line always passes through this point. Important things to remember. Alright? So now we're really going to use these equations. So, 9.1, we have this table. We made it together. We found our regression. It ended up to be 0.9838. We said that's a strong positive relationship. This was strong positive. Sorry. So between those words being typed and the minutes you had to type them, there was a strong positive regression. Okay, putting this to work. Find the equation of a regression line for typing data. Graph a scatter plot of the data and include your regression line. So we look back. Okay, we already know the sum of x, y. We already know all of these sums. So we're going to just take them and plug them in to our equation for m. M is equal to n times the sum of x, y minus the sum of x times the sum of y all over n times x squared. So we plug those values in. Put them into that equation. You will get 6. We typed about n. N was the number of x values you were given. You were given 1 through 6. So 6 times 6,842 minus 21 times 1,584 all over 6 times 91 minus 21 squared. Okay? Give a minute for you to type all of that into your calculator. Okay? So you type all that in. You end up with 7,788 over 105, which our m really is 74.171. Okay, so we have half of our equation. Now we have y equals our m, which is 74.171 times x. Now we have to find b. Find b using your equation, the sum of the average of your y minus m times your average of your x. Okay? So go back and look. The sum of all your y values, 1,584. The sum of all your x values, 21. N is still 6. And m we just found. We have all of these numbers, you just plug them in. 1,584 over 6 minus m times 21 over 6. B is 4.4. So y hat equals 74.171x plus 4.4. So we go over here to our graph. Graph your dots, your scatter plot first. Mine was already graphed, sorry. So I'm going to give you a minute to do that. Then graph your line. Graph this line in between here. All right. So now we have this regression line. If you need to pause it to finish your graph, go ahead. It's saying use our line y equals 74.171x plus 4.4 to determine if these are valid predictions. Okay? The big thing that we need to remember when we're deciding if it's valid is the domain. Our domain was all of our given okay, so our domain's all of our given x values. So we go back, we look, all of our given x values fell between 1 and 6. That's fair. Sounds great. Our x values are between 1 and 6. So we have to decide. X equals 4.5. We take 4.5, plug it into that equation. You should end up with y equaling 338.1695. You're typing 338 words, approximately words, in 4.5 minutes. That's what this says. This is your minutes. This is how many words you're typing. Valid? Absolutely. 4.5 falls between 1 and 6. It's going to fall between 1 and 6 on that line. Okay? So this is valid. All right, part B. We're given x is equal to 5.3. All right? Give you a second. Type 5.3 into that equation. Taking 74.174 multiplied by 5.3 plus 4.4. So in 5.3 minutes, you should get about 397.5 words. 398 words. 397 words. 5.3 falls between 1 and 6. In this case, we talked about this being x is between 1 and 6. So this is valid. Super. The last part. X is equal to 10. Okay? Super. Plug it in there. Awesome possum. You get out y equals 746.11. But we know this isn't valid because 10 is outside of this domain. 10 is greater than 6. Can't use it. Not worth anything. Because we're saying you can't predict this. Sometimes they got out of hand. They're not predictable. Doesn't work. Okay? This was for part B. This is part C. All right, give you a second to get that written down. So far, so good. Moving on. Next page. All right. Find the equation for the regression line given in the line given for the data given, and graph the scatter plot of the data in the regression line. The variables do have a significant correlation. I'm going to tell you that so you do not have to find it. If I didn't, you'd have to use that equation to find R that we learned in 9.1. So then use the regression equation to predict the value of y for each of the given x values if it's meaningful, meaning that domain, right? We're talking about that domain again here. Domain. To Decide if it's meaningful. If the x value is not meaningful, the predicted y value, explain why. Domain, use your domain. Okay? So, you guys need to go and find x times y and x squared. Do this in your calculator. The employment in years of 8 employees and their salaries. So, we have 2.4, 1.6, 2.0. Plug that in your L1 list. Plug this list into L2. This is L3. You find L3 by taking L1 times L2. This is L4. L4 is found by taking L1 squared. Okay? I'm going to give you a couple minutes to get this typed in. Fill out your table. Little superstars. Along with filling out your table, don't forget to put the sums down here. The sum of this column. The sum of this column. Okay, first one, x times y. These are what your numbers should look like. X squared, 576. I mean 5.76. Shoot. Okay, my bad. 5.76. Summing all of these numbers up. Ooh. Summing all of those numbers up, you're going to get 115.8. 1,634. 3,289.8 and 32.44. Give me a second to get it copied down. Oop, maybe I won't. Just kidding. If you need to get these copied down, you have to see me tomorrow in the morning before school if you don't understand how to get these numbers. Okay? Super. Okay, now we're using our equation again. M equals n times the sum of x times y minus the sum of x times the sum of y, all over n times the sum of x squared minus sum of x to the power of 2. You need to calculate your b. I will give you a moment to do all of this. You need to calculate m, you need to calculate b. For m, you should be typing in this right here, 8, because our n is 8 this time. We had 8 numbers, 8 salaries. You will get 501.2 all over 9.88 equals 50.729. Take that, plug it into your b. Plug it into your b value. Okay, you end up with 1,634 all over 8 minus m times 15.8 all over 8. You end up with 104.06. So we have this lovely equation. Y is equal to 150.729 x plus 104.06. Take that over here. Ooh, there it finally went. Okay, take that equation and graph it over here. You're having some fall above, below, different residuals there. Alright, give you a minute to graph it. Get that scatter plot graphed, get that line graphed. Don't forget your labels. Alright, super. now we go finish our lesson. Awesome. We're going to decide what the y values are for these x values. The first thing I would do is look at my domain. Are any of these out of your domain? Make sure they fall in there. We got 2,100. Yep, falls right there. 1,500 falls there. 2,500. Perfect. 3,000 is way too much. It is not in our domain, so we cannot predict it. So you don't even have to calculate it. Don't even have to calculate it. It's outside of your domain. Okay? So now we go back, we look. Type in 2.1 for x. You're going to get out 210.5909. Okay, so take your time. Calculate these. You should get 180.15 and 230.88. All right. We're just typing that into my bad. So we're just typing these things into our equation that we highlighted in yellow. So typing these numbers into your equation right here. And those are the numbers you're going to get out. Okay, we're still going to have a quiz tomorrow. You need to email me if you have questions, or come see me in the morning, or email me and I'll send an email to your advisor. So you can come right away in the morning. Okay? There is one more page. Yes, I know. I think you should do this on your own, because I promise you, if you can do this, you will pass your quiz tomorrow. Okay? Sound good? Other than that, email me with questions. Otherwise, we're good to go. And I will see you guys tomorrow, hopefully.